Hello everyone again to my YouTube channel. Today in this session, I will discuss with you the problem or the first type machine learning we have. I mean the classification problem. I will show you how we can do that with a famous framework, PyTorch, one of the famous uh, machine learning or framework we have. So today in this session, I will show you how we can implement that with the basic code and how we can use PyTorch to do that. But firstly, what is classification problem? So in machine learning, in first type of machine learning, because as I discussed in the previous sessions, in machine learning, we have types, of course. First type machine learning, we have two kinds of problem we can formulate it. The first one is classification, and second one is regression. Well, for regression and classification, what is the key or the difference key we have between both of these approaches we have? For classification problem, we have some values can be discrete value. But for regression, based on some features, based on some parameters, we can predict continue or continue value, yeah, float variable between brackets in the with the programmation languages. Float value, that means we have point. I will discuss that before deploy. I will discuss that later deploy. Let's now just be concentrated in this first type, approach of classification. Aspiration of classification problem, of course, it's coming for, or is coming for in our life. Sorry, come in our life because we cannot take in any scenario in our daily life, and we cannot discover the classification. When we wake up at the morning, we can choose to drink the coffee or the tea. This is binary classification. It's a classification. I want to choose that or that. Okay, that is classification. I mean, this classification, this process of classification is integrated in our life. Okay, but for this approach of classification, we have a lot of types, of course, of this kind of problem. We can face in binary classification. So problem types, we have binary classification. Binary classification, that means we have just two values, 0, 1, read black. We have just two options. And in relation to this approach of global machine learning, we can take in examples from the healthcare. When we go for the heart disease, for example, based on some features, we can't predict it, the person it will be have heart disease or not. We have also the problem of breast cancer of women based on some parameters. We can't predict if the woman it will be have breast cancer or not. The same things for diabetes people based on some features, based on some parameters. We cannot have ability to predict the person it have diabetes or not. This kind of this problem in healthcare is all binary classification because you have just two options. We have another types, multi-classification. When we talk about multi-classification, that means we have more than two options, more than two values. The famous example we have in this area, we have iris flower. Iris flower is a simple data set for education purpose. It's famous one because based on four parameters, four features, we cannot predict the type of flower we have. Because in this iris flower, we have three types of flower. Okay, we have another type problem is multi-label classification. The famous example we can take here, the articles in Wikipedia, for example. As we know, in Wikipedia, we have a lot of articles. At this time, we need to recognize each type from other. Here in the Wikipedia, of course, we can locate the articles of science, politics, art, sport. We have a lot of things. At this time, we can formulate this problem, try to find the best formulation for this problem. At this time, we can have the ability to predict the type of articles we have based on the data or historical data we have, or the types of articles we have in our Wikipedia. So let's start the process. So step 0, we have here the architecture of classification of non-network. Because non-network or deep learning, especially this approach, is coming famous and is coming more faster. We have exponential. We have exponential. Exponential of exponential. I mean here, this approach of deep learning is coming more faster. The progress of this approach is coming exponentially. Why? Because we have a lot of data. Before, the first trigger we can find or face using this approach is the data. Because we apply this approach of non-network, that means we have or we need a lot of data. But for now, data is available. At this time, we can just use this approach of deep learning. In the classical approach between brackets, I mean machine learning algorithms, we can also solve in this kind of problem. Okay, but for now, the deep learning technique is coming more faster and more useful in the world of business. Here, I will show you the basic architecture that we can have in this case of non-network. Well, non-network, we have a lot of types. We have CNN, for example, convolutional network. This approach is used when we have the images. When we go again in the healthcare area, based on some X-ray images, we can classify. I can take an example of X-ray image and link. For example, in case of coronavirus, I had this tutorial, short tutorial. I work it with Keras framework. When we have in the peak of coronavirus, I try to do some these things. I try to collect some available data of X-ray images of link, and I build in my basic model. We have also recurrent non-network. This approach is useful more in time series. I will discuss that deeply. I will show you also the architecture. I will show you also what's happening inside of this non-network, because that is very important to know it. I know we have now struggle between brackets because we have a lot of frameworks can do the same task. I mean, we have the ability to automate our process of solving this kind of problem. AI or artificial intelligence provide for us a lot of tools that can do the same thing. But I tell you, it is necessary to know the architecture. When we using ChatGPT, for example, to generate some piece of code, that's not enough, because we need firstly now how all these things would work and what is the process and how does things work. Because as a data scientist or as a machine learning engineer, I need to make some changes based on the problem I have. For this reason, we need to know the architecture. We need at least master one of the frameworks, because we have, for example, some problems solve it with this kind of framework. As a data scientist, if I'm newer or I have facing some projects, if I try to update or make some updates of this project, at least I need to have the idea of architecture of this kind of framework, or how all these things work. Okay, well, so for this architecture of classification only work, the first thing we have the input layer shape. Because I will show you a picture of that soil. That's very important because in architecture we have input. That means the data it's coming for some source. It will be in our architecture, hidden layers, and so on. Normally work. So here we have some pictures of that. I will show you some of them because that is very important, at least to have these things how it's coming. By the way, this non work it's coming from human brain. I mean, the aspiration of the non work is coming from human brains. The scientist, I don't remember now the name of the scientist, try to do the same things of brain work of or the human brain of the human brain of woman how it's work. I mean, it's taking the same things and try to modulate it and to make it for machines to do the same things. But so for now it's so hard because we have a lot of inputs. Well, here this is input layer. I mean, the data it's coming from here to our hill layers and output. Here in this example is simple non work is just this forward structure. I mean, it's easy one here. You have input, go to hit layer, and they will discuss deeply what's happened inside of this non work. If we take in just one example or one non work, I need to show you how that's happened. If some data is coming from here, what's happening inside of layer, and what's happened for output, and how this output recognize the data and how classified. I will discuss that deeply, but for not now. I will now just share with you the architecture of this framework. Well, so just as I show you for now, this is a simple architecture of non work. Okay. As I tell you before, I will show you what's happening inside of each hill layer here and output, of course. Well, that is very important to know. Well, let's return to our notebook. Well, we have input layer sheet in features, some as number of features here. That is important. As I tell you before, we need to decide the inputs here in our picture because we design our architecture of the problem. The second step or the second thing happen in our architecture is the head layer. I mean, this layer is hidden, is not. Well, the head layers problem specific minimum is one, max is eliminated. I mean, at least one head layers it will be in our architecture is one. The minimum is one, and the maximum is eliminated. We have famous architectures like ResNet, like we have a lot of things. It's millions and millions of non work. Okay, well, we have north per hill layer. I mean, we have the hill layers, this architecture. So let's see our picture. So this is the hill layers. So in hill layers here, this is one first hill layers. Inside of these hill layers, as we see in this example, we have four non work. One, two, three, four. Four non work. We can also hit other the other hidden layers here in this architecture with specific non work. There's no problem. Okay, we can specify the number of non work we want. Okay. So norms per hill layer generally is 10 to 512. This is the range of the number of neurons we have inside of each hidden layer. Okay, we see here the picture. We have these hidden layers and we have some numbers of non-work inside of each hidden layer. Uh, Output layer sheet out teacher per one class. I mean, here the output here. So let's return to our picture. We have here one. Here in this example, we have input layer, we have two non-work, and in here layer, we have one here layer with four nons, and for output layer, we have one here. Okay. That means that's depend of class. If we have binary class, or if we have, for example, multi-classification, at this time we have two output. Okay, it will be because we have pair one for class. Okay, and head layer activation is layer rule. Rectified line in unit, but can be others. Here, inside of this non-work we have here, we have something called activation functions. In most of cases, we use ReLU, but we have the energy. We have a law of activation function. I will show you the formula or the mathematical formula of these functions, all these functions, or the most of them, and why we use it, and what is important of these activation functions. Not now. Just I discuss with you this the architecture and show for you the principal architecture we have in the problem. Well, as I tell you before, so we have the input, we have hidden layers, we have the number of neurons for each hidden layers, we have the output, and we have inside of hidden layers, we have activation functions, and now we come into loss functions. Loss functions, as I tell you before, is the measure of errors we have. Binary cross entropy torch dot non-network dot bill loss in torch for torch cross entropy in multi-class. Here we have this cross or loss functions in case of binary and in case of multi-class classification. The loss function, as I tell you before, is try to measure the error. I discussed that before. I have some stories I discussed that deeply. The function for anyone interested, we can return to my previous playlist and see all these things deeply. And we have optimizer. Optimizer, that means steps we have to correct, to update the values. Optimizer, we have stochastic gradient descent, and we have Adam optimizer. Is one of or two of the most useful and famous optimizer we have. Okay, so for optimizer, just is the step that we can follow to make the update of our data. When we send our data to architecture, I mean the forward, yeah, it's forward, and we have forward propagation and back propagation. Forward propagation, that means we send our data to architecture, make all the operations, and in return, that's what's called back propagation. In back propagation, we try to make the updates, and to make the updates, we need something called optimizer. That means steps that we can follow to make our algorithm updated. Okay, I hope that's clear for you. So make classification data and get ready. So we will use the make circles method for scikit-learn to generate two circles with different float or color though. Here for education purpose, I don't want really to work in some real projects from data or from Kaggle or from anywhere. I can load the data and work with it. But for now, for education purpose, I just show for you that's how we can work with ready data. Here, of course, from scikit-learn for dataset, I import these make circles. I want to make circles, two circles based on some data. And to do that, of course, I will show you how we can use that using Python. Uh, well, I choose here 1,000 symbols. I choose symbols here. I need 1,000 circles or 1,000 points here. Sorry. I created the circles, and how I can do that? I treat into variables. We have x and y. I want to make circles because it's a function imported from scikit-learn. And inside of these functions, I have some parameters in number of symbols I want. In case I have 1,000, I want some noise for data, a little bit of noise data. I mean, I don't want this data to be perfect, okay? When I draw my circles, I want some red dot here, orange dot here. For this reason, I apply this noise. And of course, we have random state parameters here to apply the same dot or the same data when I run it and I run it again, okay? I send this value of 42 and I can send any value I want, okay? Here in the right, we so let's view the first 5 x and y value. I want just top 5. To do that, so I use this brand format first 5x feature. I choosing my 5 records here. Anyone also interested to this syntax of Python? We will be go to my playlist and check those things. So just as I show you here, I want really to make those things more easy, okay, for anyone interested in the area of data science, to make all these things more clear. Okay, so for the using this kind of data just to make you in the picture and in the big syntax. Well, as I tell you before, anyone interested to know the Python, also I have a playlist in my YouTube channel. Kind of check it and see the syntax of all these things. The work is easy one. Okay. And for now, we have the new language is coming called Moodle. Okay, it's not ready for now, but I swear I will make some tutorials for Moodle because that is very important. Maybe it will be more faster languages in data science, artificial intelligence in general. Well, but also Python is still strong languages for now. Yeah. Well, if we look in here, the result in my Jupyter notebook, it says some values here as we look in here. So for top 5x, we have this uh, vectors value here as we looking, okay? And for y, we have some vector also, unique vector here with some values. We have 1, 1, 1, 1, 0 here. Okay, well, that's good. We hope that's clear for you. Well, the next step here, make data frame or secret data. I mean, because I load my data from scikit-learn, I need to make it as data frame. And we know very well the importance of data frame. Okay, the data frame, Python, that is very important because we're making our data as a homogeneous structure. At this time, we have the ability to make changes. We have the ability to make analysis. So especially in this famous library we have pandas, and pandas AI is coming now. That structure is very important. Structures is very important concept. And we have also series. So in pandas, we have series and we have panda data frame. And Python, we have dictionary and we have list, we have seed. Well, the structure is very important in concept of or in the area of programming languages. Well, we have here, because as we know, if we check in here, we have just two. So if we look in these vectors, we have two values. Okay, in each vector of 5 top values, we have two values. I mean, we have x1 and x2, and that's what I try to do now with applied concept of structures. I will transform it to data frame to make everything clear, and anyone read it or around it could can understand what's happening behind it. Well, I apply this package of pandas here, so it's easy. Import pandas as PD. Well, it's a famous syntax. So I creating a variable here called circles. Circles equal to PD pandas dot structure. Well, inside of that, I creating my dictionary. So the first key here is x1, and the values that can I get here is x, all the values here for the first column. Okay, all the values of our first column. This is the meaning of this code. Okay, this is the meaning of this code. We have x, all the I want all the values for the first column here, and the second key is x2. I want all the values for the second column, x1. Okay, x0 for column 0 and 1 for column 1. And my labels, of course, it's y. I want the values of y. It will be my label or my target. And I run this circles.hit, and this is the result I get after running my code. Here, we have x1 with these things or with this value. And also we have x2 with these values, and we have my label with this value of 1, 0. Because as I tell you before, for the circles, here is a binary classification because we have two values, we have 0 or 1. Well, I will go here the next step. So how many values of each class is there? This concept is very important also. I will show you why. So circles.label, I want, so because I go to this, I choosing this. In my circles, I choosing this label, and I want to count the value of all the values we have here in my label. So for one, I mean for class one, we have 500. And for class two or zero, we have 500. Here, the observation, the data is balanced. Because in most of time, in our problem, I facing the problem is imbalanced data, especially in this case of classification problem. Sometimes we kind of facing. So if we take an example here, if for class one I have just 100, and for zero we have 700, at this time this data is not imbalanced. That means in most of time when I try to predict, I can face or we have the probability high in the case of x0 not x1. Zero, sorry, for 0 not 1. For this time or for this reason, we need to check the data how it is. Is balanced or not balanced? So in our case here is balanced because we have half, we have 1000, so half for 1 and other half for 0. So let's continue in our process here. So we need to visualize that, and how we can do that with Python. We can just apply this matplotlib famous library, and we have other one. We have okay, we have a lot of things. I remember it. We have Seaborn, we have matplotlib, we have okay, uh, we have a lot of. I don't remember it for now, but we have a lot of packages to make for visualization. Where to do that? Just I need to make scatter all this point here. To do that, just will apply this matplotlib library. In this case, import matplotlib.pyplot as plt. So it's a short or as alias. plt.scatter x for first variable x equal to x. I want all the values for class 0, and for y here I want all the values for class 0. I have two variables here, x and y. So first, for x, small x here, I want all the values for column 0, and for y, I want all the value for column 1. And for that, I want sim up, it will be, of course, read value. Here, documentation is for here, Well, after running, this is the shape of the skaters that I will get here. Circles, we have blue one and red one. Well, this is shape that I get here. This is for x and this is for y. Okay. Well, this is the values here for x. So for this x red one here, this is all the values I get here. So as we look, okay, these are the values we have. 500 points. So 500 points is represented in this circle, and also for this one. Okay, we have two circles here. I hope that's clear for you all. So if we still continue, shape is very important because in the most of time we kind of facing this problem, this trigger. I cannot able to formulate or shift my data. For this reason, I need to check each time the shape of my data, how it is. So to do that is easy. We can just apply this function of shape is predefined in Python. For in our case, we have x dot shape. We have 1000 and we have two columns. For y, we have just 100 because we have the input. And if we look in the shape of y, it's clear because we have just value 0, 1, 1, 1, 1, 0, 1, 1, 1. That's why we have 100 response or 100 value for this target variable. Well, so looks like we got much of the first dimension of each. So if we look in the first dimension here, we have the same, okay, the same dimensions. And for two is for, because we have two features, two variables. We have x1, x2. But what's the second dimension on x? If often helps to view the values of shape of single simple feature and labels. The ways will help you to understand what input and output she will be expressing for your model. Well, okay. Well, here x simple. So view the first example of features and labels. To do that, I created the same these variables. We have x simple equal to x for first value. For y simple also we have y x, okay. So we print value for some values for one simple for x. I want x simple and second for y simple. And also here shape of one sample of x. I want shape x simple and same for y simple. So if we look in the result here for value sample, for sample we have this vector because I chosen just one. I'll show you. So in our goal, I chosen just one vector. I'll show you here. Where is? So I chosen this one because I want x0. X0 that means first point. So I chosen this. Okay, chosen this two. But the first vector with two values because we have x1 and x2. And for y, the result is 1. So if we return to this one to make all these things clear, so the label is 1 because I choose here. I want this the index of 0 and is 0. So the indexing the 0 content this value this vector, and the response or the result is equal to 1 here as we see. I hope that's clear for you. Uh, we want just to discover the pattern for the wheel. So the shape for simple we have to because we have two values as we see, and for one it's none because we have just so it's 0 maybe or 1. Let's consider it 1 here. So this tell us the second dimension of X-Men. It has two features, vectors of course. Whereas y as a single value is a scalar because we have a scalar. It's a one value. Okay, one value, but for x we have two values, which means it's a vector. So we have two inputs for one input. Here we can just understand that we have two inputs because we have two vectors, x1 and x2. x1 here and x2 here. And for output it will be 1 because it's a scalar. If we check in the values of all these y target, it will be get 0 or 1. I mean, we have just one value, it's a scalar. But for the vector, we have two inputs two values. In the header layer, we have some operations here, and the output is will be 1. I mean, one values will be 0 or 1. That's different. I hope that's clear for you all. So turn into tensors and create train and test splice. So before trying to do anything, we should first uh, make this transformation for our data as tensors. We need to transform it to tensors to make it more faster for that. To do that, we can just using this torch. Torch, torch here is our framework, and we have y equal to torch dot from numpy because I take these vectors, those type torch float. I need to make it as a torch float. Here, the torch, I trace the float type here. Same things for y. Torch dot from numpy because it's coming from high level competition. It's numbers, and they want to make it as a float. If we check in here, we have point here. That means it's float. If we check in the tensor for the y target here, it will be a tensor or will be take it will be a float type. Okay, it's not integer. Now our data is tensor format. Let's split into training and testing C. Because here that is very important. Before trying to do all these things, before transformation to make it from numpy to tensors, we need to make this test and train data, training and testing, because we need to train our model to have this strong uh, shape or strong pattern. After that, it will test our model to see the accuracy of our model how it is. So to do so, let's use in this helpful function train test split. It's provided in scikit-learn. We will use its size here, just 0.2, I mean 20% for just testing, and we have 18% for training. Because splice happens randomly across the data, so let's use random states is 42, so splitting is representable. Here, why I using this random state again is just for if we're running again and again, we need to return the same values here. So to do that, from scikit-learn.model selection, I import train test split. This function is here. It exists in our uh, packages. Just we need to import it. Well, x train y train or x train x test y train y test. Here we are creating 4 variables, and we need to assign each of these variables some values. Train test value here, I want to make in this train test split for x and y. And test size, as I tell you before, we want just 20% for testing and 18% for training. And the random state, make the random split very predictable. I mean, if we run our cell h again, we need to return the same values. So we need now to check in the length of each of these variables we have here. So the length of x prime is 800. Length is 20, 20, 80. So we see the length of y train and x train. Okay. So the next step here is to build in our model. Okay. So to build in the model, we've got some data ready. Now it's time to build in a model. We will break down into a few parts. So setting up device agnostic code. So our model, it can run on CPU or GPU, so it's available. So in the first tutorial on the PyTorch, I explained that deploy. Why that is very important. Second step is constructing a model by classing the model. The third step here, defining a loss function and optimizer. That is very important. We need to specify which loss function we work with and optimizer also. Creating a training loop. This will be next section. Okay. So the good news here, we've been through all the above steps before in notebook. So one, because I discussed that before, I built it that before. So anyone interested, you will just check the price of PyTorch and they will get that. it will get that, sorry. Except now we'll be adjusting them to work with the switching dataset. Let's start and be important by torch and torch in as well, setting our device and not input. Well, so the first thing we can do it here just to tracing our device here. So import torch, from torch import non-word device. I creating a variable called device here. Coda. If torch coda is available, else CPU. So if coda here, I want to work in coda, but it's not, if not is available, I want tracing the CPU. That's what's happened here in my case because I run all this code in my Jupyter cloud. Okay, I not work in my local environment. So I working with CPU in this case. Okay, excellent. Sorry. Now device is set up. Okay, the CPU. Now we can use it for any data model. We create and PyTorch will be handled on CPU default or CPU if it's available. Okay, now how we can create in our model? Well, how we can create model? We want model able to handle our X data as input and producing something in the shape of our data as output. Here, what is the idea or what is the purpose or what is the goal? Is we have some input and we have some input and we want some output. So here, in other words, given X features, in our case, we have X1 and X2. We want our model to predict Y, label the target. Setup we have here features and labels is referred to as supervised learning because your data is still in your model. What's output should be given a certain input. To create such model is need to handle the input and output shapes of X and Y. Shape is very important, of course. Remember now I said input and output shape are important. Here we'll see why. Let's create a model class that shape class is non-word model. In most PyTorch model are shape class of non-word. So most of models is exist here in non-word model. Second step, create two non-word layers because we have two, one and two, and the constructor able to handle the output and output shapes for X and Y. Define forward method containing the forward path computation of the model. And fourth step here is instantiate the model class and send it to the target device. Here, I will show you that's why. So construct a model class. It's a class in non-word. I create my class here class. I created the class called circle model 0. So I make the inheritance from this non-word model class. That's also is very important. In Python, I explain that deeply. I explain what is the instantiate class, inheritance, how I can create the class, how I can create subclass. Okay, anyone interested, we can go just in my playlist to see these things. Well, I creating the constructor here. If init self, I want the methods of my non-word model to do that. Just I want apply this function zipper dot unit. I want constructor of my zipper class. Create two non-word class able to handle X and Y input and output shape. So self layer 1 is non-word. In features, I want two. Okay, two inputs. Outlier or out features, it will be 5. Take into features X, produce 5 features. And second one, self layer 2, non-word features, it will be 5, output it will be 1. Take in 5 features, produce 1 feature Y. Define forward method containing the forward path computation. I create this forward because we send the data self for X. Return the output of layer 2, a single feature, the same shape as Y. Because as we see in for shape or for layers or for target, it's one value, it's a one output. I want to return the layer 2, self layer here, 1. Computation goes through layer 1. First, in the output, it will be goes through layer 2. Okay, goes here, This is architecture. Well, it's just input and one output. I create create an instance from the model. Model 0 is a circle model to device. I send it to my device in CPU, I mean. Okay. And this is the result here. Model says here, I send, says here, parameters. Also, we have the other. This is the first method, how I create a model from my class. Here also, I do the same things with sequential. Model 2 is no-name was sequential. No-name was layer is in feature as 2 inputs and output is 5. In feature is 5 and output is 1. 2 devices. I send to my device, I get the same result. So, whoa. So this look much simpler than C in model. Why not just always seeing or using this non-linear sequential? Why? Because we have one reason. Non-linear sequential is fantastic for straightforward computation. I mean, we have just simple architecture. So in this case, you can use sequential because source of data it will be here and source for output it will be here. It's a simple one, simple architecture. Okay, for the way we can use sequential here. So if something is to happen rather than just straightforward computation. So if we have other form, not we have the structure is not straight forward sequential. At this time, we need to use something other. At this time, we can create in our class or instantiate from this class we create. So we will want to define your own custom model class C++. Now we put the model. Let's see what's happening when we pass some data through it. So now we want to make a prediction of model. To do that, int predicts equal to model, my model test or x test to device. I send my training test to my device and see what's happened. So for print, the length of predictions. I want the length of predictions. I want the length of predictions. So I have length int breeds here. Shape int breeds dot shape. Okay. The length here is 200. And we see before that, after splitting and testing of data, I see the length of X train and Y train, uh, Y train and length for train Y. So I print first 10 predictions in print press 14. Print 10 first label here and see the result. So I make the predictions here. Okay, I make my predictions. I predict here. Okay, press. I see just 10. I want 10 here. See, first predictions here. Okay? And also for why we have this result. So the second step it's coming here is the loss function. I need to measure the error. How the error is. How the error is. Okay. To do that, step loss function and optimizer. Because I measure the error and I need the optimizer to correct this error. The optimizer, as I tell you before, it's step because we have forward propagation and in back propagation, I need to update those values. Loss function, also called criterion or loss or cost function. Different problem types require different loss functions, of course. An example of regression problem, I mean, predict continue number. You may use in mu, mean absolute error. I discussed that before. But in our case, in binary classification, we will use binary cross entropy. The same thing with optimizer is a law. We have a lot of optimizers. So in, for example, stochastic gradient descent optimizer, it can use it in range problem. I mean, we have a lot of problem, we can use this CD or stochastic gradient descent. And the same applies to Adam optimizer, Tosh optimizer.adam. And they make for you here some different functions. So stochastic gradient descent optimizer, we use this type of problem when we use this optimizer. We can use it in classification, in regression, and many other problems. And to apply it in PyTorch, we can use using PyTorch.optimize SVD. Adam optimizer, the second one, can use it in classification, can use it in regression. And we have torch.opt.adam if we want to apply it. We have numerical entropy loss, we use it in binary classification. Binary cross entropy loss, we use it in binary classification. To apply it, we can just use pytorch.non-reward.fill loss without locked or torch not BL clause. Mean absolute error or L1 regression torch dot non-reward L1 loss, and mean squared error or L2 regression torch.n.L2 loss. I discussed that before. Okay. So I hope that's clear for you all. I not want I want really I don't want really to make this tutorial more long than that. I will divide this session. I will continue in the next session to show you more important things. Okay, so we will more discuss with you a lot of things. So here is a visual tool provided by TensorFlow. Okay, that's help us to show you these things how it's happening. So in related to our problem, we have two inputs x1, x2, and we have in layers. We have 5 non-work here, so we can add. Okay, that's different. So if I run that, we'll discuss and see here the number of epoch we need to things here, and the learning rate here is the optimizer. Division here in our case is the NH, so we can trace in Bulu, choosing the Bulu here and then run again and see the difference here. So how this noise make it here. We have some noise point. Okay. There is no regularization here, we don't want it. Okay. The number of epoch increase, and we see the shape here, beta how it is. Okay. I hope that's clear for you all. Thank you again and happy learning. See you again.